Map Interpretation, Part 1. Basics of Map Reading and Interpretation. Introduction to Map Reading. Map reading involves understanding and interpreting the information conveyed by maps. It includes recognizing symbols, understanding scales, and identifying geographic features. This skill enables individuals to comprehend spatial patterns and relationships in both physical and human geography. Methods of showing relief. Relief refers to the representation of the physical features of the Earth's surface, including elevation, slopes, and landforms. Various methods are used to depict relief on maps. 1. Pictorial methods. Relief is shown through drawings or sketches of landscapes. Techniques include hill shading and hachures, where shadow and lines are used to indicate elevation and slope. This method is visually intuitive but less precise. 2. Mathematical methods. Relief is represented using quantitative measurements, often involving contour lines, spot heights, and benchmarks. Contour lines, lines connecting points of equal elevation. The spacing of these lines indicates the steepness of slopes. Spot heights indicate specific elevations of points on a map. Benchmarks, permanent marks indicating known elevations. 3. Combination of pictorial and mathematical methods. Combines the advantages of both methods for better visualization and accuracy. Example, maps with shaded relief, pictorial, overlaid with contour lines, mathematical. Significance of relief representation. Navigation and planning helps in determining the best routes for travel or construction. Understanding landforms assists in studying geomorphology, hydrology, and settlement patterns. Military and disaster management, critical for strategic planning and hazard mitigation. Conclusion. The basics of map reading and interpretation form the foundation of geographic analysis. By understanding how relief is depicted through various methods, one gains the ability to analyze landscapes and their features effectively. Let me know when you're ready for the next part. Map Interpretation Part 2. Interpretation of Gradient. 2.1 Slope Determination. The slope or gradient represents the steepness or incline of the land surface. It is critical for understanding terrain and planning activities such as construction, farming, and transportation. Methods to determine slope. 1. Using contour lines. Contour lines indicate elevation changes. Close spacing represents steep slopes. Wide spacing represents gentle slopes. 2. Formula for gradient. Gradient equals vertical interval, VI/horizontal distance, HD. Vertical interval is the elevation difference between 2 points, while horizontal distance is the ground distance between them. 3. Graphical representation. Slope maps or profiles can help visualize steepness across a terrain. Hatcherstadt 2.2 Understanding contour profiles. A contour profile is a side view or cross-sectional representation of the terrain along a specific line on a map. Steps to draw a contour profile. 1. Identify the line of section, e.g. AB on the contour map. 2. Mark elevation points along this line. 3. Transfer the elevations to graph paper with the x-axis representing the line of section and the y-axis representing elevation. 4. Connect the points smoothly to form a profile. Applications. Useful for road or railway alignment. Helps assess flood risks and water drainage patterns. 2.3 Techniques for identifying intervisibility. Intervisibility refers to whether one point on the terrain is visible from another. Key techniques. 1. Cross-section method. Draw a line of sight between 2 points on a contour profile. Check if any terrain elevation intersects this line. If so, the points are not intervisible. 2. Using gradients. Calculate and compare slopes between the points of interest. Applications. Designing communication towers and signal routes. Analyzing viewpoints for tourism or strategic military planning. Other gradient concepts. 1. Cross-sections. Vertical diagrams showing elevation changes between 2 points. 2. Gradients and similar triangles. Gradients can be analyzed using the properties of similar triangles, where proportional relationships between base lengths and heights are utilized for calculations. Conclusion. Understanding gradient and slope interpretation equips us to analyze terrain more effectively. From determining slope steepness to assessing intervisibility, these skills are vital for applications in geography, engineering, and land use planning. Let me know when you're ready for part 3. Our map interpretation, part 3, interpretation of topographical maps. Topographical maps are detailed representations of the Earth's surface, showcasing both natural and human-made features. They are essential for geographic studies and practical applications like land use planning and environmental management. 3.1. 1. Marginal information on maps. Marginal information provides essential details for understanding the map, indicates the map's purpose or area covered. Scale shows the ratio between map distance and actual ground distance. North arrow indicates orientation. Legend key explains the symbols used on the map. Grid references help locate specific features. 2. Conventional signs and symbols represent physical and cultural features such as roads, rivers, and settlements. Examples include blue lines for rivers, green areas for vegetation, black lines for roads or railways. 3. Concept of sheet number. Maps are divided into sheets for manageable coverage of large areas. Sheet numbers help users reference a specific part of the map. 3.2. Interpreting physical features. 1. Relief and slopes. Identify elevation and slope using contour lines. Concave slopes. Contours spaced more widely at the bottom and closer at the top. Convex slopes. Contours spaced more closely at the bottom and widely at the top. 2. Physiographic regions. Recognize landforms such as mountains, plateaus, valleys, and plains. For example, steep contours may indicate a mountain. Flat areas with sparse contours may indicate plains. 3.3. Interpreting human and cultural features. 1. Settlements. Shape, size, and distribution of settlements provide insights into human activity. Linear settlements often follow roads or rivers. Clustered settlements indicate fertile land or resources. 2. Infrastructure. Roads, railways, and bridges highlight connectivity and development. 3. Economic activities. Land use patterns such as agricultural fields, industrial areas, or forests suggest economic activities. 3.4. Understanding land use and spatial patterns. 1. Communication networks. Analyze roads, railways, and waterways to understand the level of connectivity. 2. Relationship between physical and cultural features. Physical features often influence settlement locations, agricultural practices, and industry placement. For example, settlements are often found near water sources or fertile plains. Industrial areas may align with mineral resources. 3. Spatial patterns, distribution, and density. Look for patterns such as urban-rural gradients, clustering, or linearity in features like roads and settlements. Conclusion. Interpreting topographical maps requires understanding the interplay between physical and human features. By analyzing relief, slopes, settlements, and land use, one can draw meaningful insights into geographic patterns and processes. Let me know when you're ready for part 4. Hammer Map Interpretation, Part 4, Interpretation of Geological and Weather Maps. This section focuses on understanding geological and weather maps, which provide critical insights into the Earth's structure and atmospheric conditions. 4.1. Geological maps. Geological maps display the distribution, nature, and age of rock formations and structures at the Earth's surface. Key features. 1. Definition and use. Geological maps are used for resource exploration, land use planning, and environmental studies. They show rock types, geological structures, and relationships between them. 2. Types of geological maps. Lithological maps show different rock types. Structural maps highlight folds, faults, and other structural features. Stratigraphic maps depict layers of rock in chronological order. 3. Key elements. Outcrops. Exposed portions of rocks visible at the surface. Bedding, layers of sedimentary rock. Their tilt and direction indicate geological processes. Unconformity, a surface indicating a gap in the geological record. Folding and faulting. Folding, bending of rock layers due to pressure. Faulting, breaking and displacement of rocks along a fracture. Strike and lineament. Strike, direction of the line formed by the intersection of a rock layer with a horizontal plane. Lineament, linear features on the Earth's surface representing geological structures. Pesh 4.2 Weather Maps. Maps illustrate atmospheric conditions over a region, including temperature, pressure, precipitation, and wind. Key features. 1. Differences between weather and climatic maps. Weather maps represent short-term atmospheric conditions, such as daily or hourly updates. Climatic maps show long-term patterns like average rainfall or temperature over decades. 2. Signs and symbols in weather maps. Isobars, lines connecting points of equal atmospheric pressure. Isotherms, lines connecting points of equal temperature. Wind symbols, arrows indicate wind direction and speed. Fronts represent boundaries between air masses. Cold front, marked by blue lines with triangles. Warm front, marked by red lines with semicircles. 3. Key elements to interpret. Pressure systems. High-pressure systems, anticyclones, often bring clear weather. Low-pressure systems, cyclones, are associated with storms and precipitation. Rainfall and cloud cover, shown using shading or symbols. Temperature variations. Isotherms help identify regions of varying heat. Pesh applications of geological and weather maps. 1. Geological maps, mineral and energy resource exploration, identifying earthquake-prone areas and mitigating risks. Planning construction projects like dams and tunnels. 2. Weather maps, forecasting daily weather conditions for agriculture, aviation, and marine activities, tracking storms, cyclones, and other natural disasters, analyzing climate trends for environmental studies. Conclusion. Geological and weather maps are invaluable tools for understanding Earth's structure and atmospheric processes. While geological maps reveal the dynamic history of the planet's surface, weather maps provide real-time data crucial for planning and safety. This concludes the detailed explanation of map interpretation. Let me know if you need further clarification or additional topics explained.